Intro, the first thing I'm going to ask you right off the bat is turn on your calculator, and you should see at the top here, if it says degrees on your calculator, we need to change that, okay? We need to change that. So we're going to go mode, and then we're going to go to the line where you have the choice between degree and radian. And we're going to select radian, okay? No more degrees. We're only sticking to radians in this course, okay? So we don't do any trig. So because we're doing sinusoidal function, that's a trigonometric function, we're dealing with radians, okay, not degrees. So once you select radians and you quit that, at the top of your screen, it should now say radian, okay? So that's number one before we get started. Leave it there, do not change it. You should be fine once you've changed it. Okay, that's step number one. Step number two is if you look at the sinusoidal function, this one is very unique in this sense, guys. It repeats itself over and over. It repeats itself. So if you start at any point along the graph and you move on, you will at some point come back to the same height that you started. So kind of like parabola, except for how is this different than parabola, than quadratics, is that it just keeps doing that over and over again. It's always like a wave. So you go up, you go down, you go up, you go down. It's like you reach the lowest, then you reach the highest, and then it just repeats itself over and over, okay? So that's something, it's a cyclical function. It's a periodic function, okay? So I will say this at the front here, in your by your covers, cyclical or periodic. Okay? And it means it repeats itself. So the tides of the ocean, right? That repeats itself. The number of hours in a day, right? It just repeats itself over and over again. So a lot of cyclical things in nature that we can observe. Okay. All right, let's continue moving on. This one here is just saying that why we are using radians. So we're using radians because it's an alternate way to express the size of an angle. Okay. So one thing I want you to remember when you're thinking of radians, okay, you have to think of it this way. That for us, let's say this would represent 0 degrees, okay? If we go all the way up to north, the vertical, that would be 90 degrees. If we do another 90, that would put us at 180 here. Another 90 would put us at 270. And then we actually get back to 360, right? So if you go up on 90-degree increments, that's what it would look like if we use degrees, okay? It turns out that we can also refer to an angle measured using radians, okay? So this would be a full 180 would be just pi. And another pi would get us to 2 pi. Okay, so when you're using radians, we would start at 0 radians. If a full 180 is pi, then half, like a 90 degree, would be pi divided by 2. So this is pi. Another half a pi is 3 pi over 2. And then back to 2 pi. So I will say radians on the outside and degrees on the inside. Let me focus this a little bit. So basically, instead of me saying, hey, we want a 90-degree angle, I could just say, I want an angle that's pi over 2. And you're like, what? Yeah, that's in radians. We measure that angle in radians. Okay, and that's the main biggest difference. So it's just two different ways of referring to the measure of an angle. And so we stick to radians in this course. Okay, so our calculator needs to be set to radians. By the way, let me just remind you, what is pi? Pi is what as a number? 3.1415, and it keeps going, right? It's indefinitely. So 2 pi would be 6.28, and that keeps going, right? So just so you know, when we talk pi, we're actually talking about the numeric value of pi. But it's just too annoying to write out the decimal, right? So we just use pi. It's an irrational. It's a rational number. Okay, let's keep going. Here's where we look at a sinusoidal function. Some terminology. Page 3. And I tell you stop, change from degrees to radians. We did that already, so we're good to go. Okay, so when we deal with data that appears to have a repeating pattern in regular intervals or cycles, we deal with periodic functions. Okay? A sinusoidal function is any periodic function whose graph has the same shape of that of y equals sine of x. The amount of units along the x-axis for a full cycle is what we know as the period. Okay, so that's important. The amount of units along the x-axis for a full cycle is called a period. Usually this is the time it takes for a full cycle to complete. Okay. The units will always, I will use a different color for this one. Let me use my green here. The units will always be what's on the x-axis of the graph, and it's always a positive value, so don't be coming up with negative periods, okay? Then we have something called the midline, also known as the median. It's also a very important term. It's the horizontal line that's halfway between the maximum and minimum along the y-axis. And then you've got the maximum, which is the highest point. Maximum is the highest value. And minimum is the lowest value that this wave reaches. So you've got period is like how long does it take for a full cycle to complete. Midline is the halfway mark. It's halfway between the max and the min. Then you have your actual max and min. And now it's the amplitude. I'm running out of highlighters here. The amplitude. The amplitude is the distance from either, right, the distance from either the midline to the max or the midline to the min. And it is always a positive value. So I'm going to give you a little summary here in way of graph, of a graph, so you can see it visually. Okay? So if you think of a wave like this, okay, just do a couple that it looks like that. Then we have the midline, or also known the median. The midline cuts this thing right in half. Okay, so it kind of figures the highest and the lowest point, and so that is what we call the midline. And then we have something, so this is the midline, and you know that there's always a max here. Like that point would be the highest value, and then you have a min here, the lowest value. There's the max, and there's the min, right? So that once you figure out what the lowest value is, so let's say, you know, the depth of the water goes down to 3 feet below a certain measurement, then it'll always stay at that 3 feet below, okay? That's like the minimum, and then you've got your max. And so the midline is right in between that distance that exists between the lowest and the highest value. And this is the amplitude right here. The distance between the midline and either the max, so this is amp, okay? This is amp. Is it hard? It's probably hard to see, I apologize. But that is the amplitude. Like if you go from the midline to either the lowest point or the midline to either the highest, that distance is what we call the amplitude. And it also stays the same once you've determined it. Like that stays the same. Doesn't change. So max is the highest, min is the lowest. Midline is the mid, you could call this the midpoint. And the amplitude is that distance between the highest and the midline, or the lowest and the midline, okay? So hopefully that helps you visualize this a bit more. And here is the only form of this function that you will ever encounter. It looks like this. Some of them could be 0, right? But the one that can never be 0 is A, right? And B cannot be 0 either, because then the whole thing would turn into 0, right? You won't really encounter that. Okay, so I want you to have this formula on your study sheet. So the amplitude affects the max and the min, right? Can I just put a little subheading here? How each affects graph, okay? I'm basically telling you how changing each one of these A, B, C, or D's, the A, B, C, or the D, how does that change my graph, okay? So the A will affect your max or your min, okay? B affects the cycle of the period, or the period, sorry. Affects the cycle or the period. So this one is important here. If B is increased, you will have something like this. The bigger you make it, the closer together the waves are. If B is decreased, you're going to have a longer wavelength, okay? So that is specifically for the value of B. It affects your cycle or the period, how long it takes, okay? C, it affects the horizontal shift, right? It's a horizontal shift. So basically what I will ask you to do is, I will say make a wave like this, okay? If you were to change C, and I'm going to show you that in a bit, okay? If you change C in any way, you will cause a shift. So like if you started here earlier, maybe start over here and try to do the same thing. Right? So this point over here got shifted. So you're going to shift the whole curve either left or right. Okay, that's what it does. So cut it there. And D affects the vertical shift. It is the midline. That is the midline, but it will affect it. If you increase it, it will go up. If you decrease it, it will go down. So what I'm going to do is I'm going to start with my curve here. And then I'm going to have one over top of it. So think of this as my reference point. If you increase D, every point is going to be increased by the same amount. So this is if you increase D, it's going to cause the whole thing to shift up vertically. And if you drop D, if you change this down, it would affect it this way, where D is decreased. Okay. So you're shifting, you're bringing it down. And I think I still want to do something with A. I haven't done that before. But I will say this. If A is increased, okay, then your curve will also get higher and lower. Okay? Because what you're doing, if you think about it, is you're increasing A. You're making the caps be further away from the midline, right? The more you increase it. If you were to decrease A, if you were to make it smaller, if this is your midline here, they would actually come closer and it wouldn't be as exaggerated, right? So it will, these caps will come closer to the midline if you decrease it, right? So that's the effect that A has on the graph. I would like you to have this, and right now you can fill up your study sheet with this unit. This I would strongly recommend you have that on your study sheet. I'm actually going to I'm going to highlight the whole thing. And I'm just going to pause this here for 1 second because I want to have my eye. Okay, so I'm just going to recap because it didn't record. We got the equation A, B, C, D. We identified each letter, and then we figured out, using the equations on the previous page, we figured out all these missing pieces of information. Now we're going to try to graph it using our calculator. I'm just going to make sure you can see it. There we go. So if I graph this, I don't know, were you able to see it? Yeah? Can you do a zoom standard all, so we all see the same thing? So that's our standard. So this one works, and not surprisingly, because we go down to -3 and as high as 7. So a standard window will work just fine. But what if we want to see, most of the time, guys, we want to see more in the positives. We want to see as much as possible. So we're probably going to have to expand our X max most of the time. One thing to mention here, guys. Can I see at least one full cycle? And the answer is yes. You know how you determine a full cycle? When you can start at a max, go all the way down to the min and then back to the max, you have yourselves a full cycle visible, right? same thing here. If you start at a low and you go to the high and back to the low, this is considered one full cycle, okay? So you always want to see at least one full cycle. So if you don't, let me just play around with my window here a bit. Let's say I went to 5 and -1. Is that a full cycle there? Not a full cycle, right? Because you have the max there, you go to the low, but you can't see that other half of your curve. That's not a good window. Okay, so I'm going to go back to zoom 6. This is actually not bad. So let's investigate. If you wanted to find the minimum, and some students are like, Mr. Dirksen, there's 2. Which one is the minimum? If it's the lowest point, it doesn't matter which one you find. So I'm going to go second trace. I'm going to go minimum, lowest. And you got to, let's say you want to focus on this one. Notice what it says. It says left boundary. So if this is the lowest point, you got to go to the left. Hit enter. Go to the right. Hit enter, and then enter one more time. And do you notice that the lowest is -3, right? I hope you saw that. So we verify that that's true. If you wanted to find the highest point, you go second trace max. And then you got to go to one of the highest points. So you hit enter, right? First left, then right. And then now it's going to find it. Oof, I pressed 1 too many times. Well, I think I'm fine. But it's 7, which is what we expected. Okay, so that's something to verify. One more thing, though, the period. How do we figure out that it is 10? Okay, I think I'm going to leave that for a little later. But you know what it is? 10 is basically if you were to look along the x-axis and count how many units does it take from the first high to the next high, the next max, like that's 10 units horizontally. That's what the period tells you. Okay, guys? Or from the low to the low, it's 10. Let's count. You can approximate, watch. If you count here, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, and something. There's something here, and there was something there, so it is 10 if you round it. We can find that out exactly, so you don't have to worry about it too much now. But that's what the period would tell us. And the midline is 2. How do we know that? That's just given to us by the equation. Can I ask you to graph the midline real quick? We're going to go to y equals, go to y2, make that equal to 2 real quick. And then you see the midline, and that cuts this perfectly in half, right? And your amplitude is the distance from here to the top or from here to the bottom. That's the amplitude right there. So that's how you visualize it. Okay, one more thing. I have to say this. The double brackets. Please watch out for the double brackets. So some students, when they, I don't know, sometimes they put 2 brackets and when they type this in. So they go 5 sign and then they go another bracket for some reason. It has happened several times. It's a completely different graph. So please refrain from doing that. As soon as you press sign, there is a bracket. So don't be pressing bracket, right? Like don't do double brackets because that happens. So that's why I made a note there for you to, because that's a completely different graph, okay? Okay, graphing with no context. So let's go ahead and graph this now. I will break my rule here a little bit because it's actually just fine to do that. We're going to attempt to graph this thing. We're going to attempt to graph this thing on paper using the calculator to aid us. Okay, so down here, we're going to just go ahead and call this x and y. Okay. And a lot of times they want you to have at least 2 cycles. The province often asks graph this, including at least 2 cycles. So what we're going to do is, let's go to our graph here real quick on our calculator. Do we see 2 cycles in here? Let's try starting here. This would be 1 right here, right? I need another one. Because no matter how you slice this, from here to here is 1 cycle, sure, but you don't have 2 consecutive cycles. So let's go to Window, and our X max. What is our period, guys? It's 10, right? So 2 periods would be 20, correct? So I'm going to make this, I'm going to turn that to like 25, just to be safe. But then at least you have an idea. And you're like, Mr. Dirksen, it's a different graph. No, it's not a different graph. You just see more now in that same little screen you have. So we're going to start here. That is a cycle, and that is another cycle. Okay? So we're going to do 2 cycles. So let's start with this point right here. Let's go ahead and find it. Second trace max. And I'm going to actually find the exact coordinate of this point. So I'm going to go left, right, enter. Okay, so watch what I'm going to do here on the side. First max that I determined is negative 0.297. Let's go find the next min. Okay, right next to it. Second trace min. It always asks you for a point to the left, hit enter, a point to the right, hit enter, enter. This is 4.71 negative 3. Got it? Okay, so we're going to go plot them. For this to work, I'm going to go, does this work? 5, 10, 15, 20. I think that's going to work. Yes, it's going to work. So 5, 10, 15, 20. So every box is worth 1 for me. And I'm going to do the exact same thing along the y-axis. Got it? And these are reference lines right now that I'm adding. My max is 7, correct? So what I like to do is I like to go to 7 here and just make a dashed line. It's going to help you a lot to have these lines. Y equals 7. And the lowest we get to is negative 3. So I'm going to go down to negative 3 here and make a dashed line there. The way I would say is these are not critical, like these are not a must, but I would say they help me a great deal when I'm graphing this. Let's go on our x-axis and turn this into negative 5 here, going 5 back. So let's start with our first max, which is almost on the y-axis, but not quite. So negative 0.29 is like right there. Right there. And our first min is 4.71 negative 3. And I'm going to show you the trick here now. Because close enough is good enough for the province, okay? How many units is it going to take to get back to the top here, guys? How many units is our full period? We determined it's 10, right? So it's going to be from here. It's not going to be exactly on 10. It's going to be slightly off to the side, correct? Because from here If you add 10, you're almost at 10, but not quite because you started a little off to the left. So this is your next point, got it? Let's add another 10. We're going to get to right there. So I will do this for your notes. This is 10. I don't really need you to do this. I actually don't want you to do the bracket thing that I'm doing right now. Don't do that on your actual graph. This is just for reference. However, this is not good enough because you also need some points to help you down here. How many units is it going to be from here until it gets back to the lowest? 10, right? It's 10. It's always like from low to low 10, from high to high is 10. So what is it right here? This is 4.71, right? Add 10, we're at 14.71. Oops, that's not a point, that's a something else. There we go. So this is also 10. So let the period help you here. So now let's go ahead and graph this. So you go a little bit, you start earlier, you go to the max, get down to the lowest, and you go to the max, down to the lowest, go to the max, and just continue it because it doesn't tell you that it stops there. Have arrowheads there, and voila, you got it all done. I'll just say period. So what did I do? I used my calculator for this one. I will actually mention that in your notes. Calculator, calculator. Like I figured out the exact location of those. And then I used the period to figure out my next points. The only thing here is warning, the period could easily be 6.35 or something. So then you just have to add 6.35 to wherever you started to help you figure out where am I next. Okay? So I will make a note here. Graph includes 2 full cycles. 2 full periods, 2 full cycles, whatever you want to call that. I will say this, that QR code is there to help you out. If you do the QR code, I'm doing it a bit more, it's more complicated because what I do on this video is I tell students, find this point, find those, like I find all of them individually, but the province has told us many times that close enough is good enough. Meaning, if you're within a decimal, you're fine, right? Obviously, if you put the point somewhere over here, that's too far off. You can't be off by a whole unit, but you can't be, like, as long as the point is somewhere in that neighborhood where it should go, that's good enough, okay? So find these, and then use your cycle to find more points, and then you've got your 2 full cycles in this case. Okay? If it asks for 3, you'd have to do this one more time, okay? So hopefully that helps you. So you got to use your calculator, obviously, to get started. I'm going to continue a little bit more, guys. I know you're... Yes, go ahead. This is also study sheet, a study sheet entry, guaranteed. Formulas to determine the characteristics of a sinusoidal function from the graph. So you get it from the graph. You figure all of this out yourselves. This is on page 5. Okay? So how do you figure out the period of the function? One way of doing this is you simply take this, and and you subtract the x values that you found here and here. Okay? So this is x1, this would be x2. So you go this one minus that one, you've got your period there. That would be one way of doing it. Or, it says or right here. Let's say you're going like this. This is all that you're given perhaps. And then you would go from here to here. This is x1, this is x2, and you just subtract those two. That would also give you the period of this function. Okay? Or I have to give you this because they have done that several times where they don't give you the full picture. Let's say the province does something like this and they just leave you there. Right? They kind of keep going a little bit, but not much else is given. They just give you this and this. That is not a full cycle, guys, right? They're not showing you a full cycle. But this would be the max, and this would be the min. And remember, when it comes to the period, we're talking horizontal. It's the x values that we're interested in here. So you would simply go 2 times whatever you see here. So if you subtract, like let's say this is 3 and this is 5, you go 5 minus 3, that's 2. You double it, and then you get your full period. Okay, guys? That's why I give you 3 different variations of that. The amplitude, it's the y max minus the midline. That's one way of doing that. Or it's the y min minus the midline. Okay, so it's either one that will help you out. I just have to say it's always positive. Always positive, right? So the amplitude, once you state it, once you've calculated it, make sure you state it as a positive. So there's or, and another way is to go y max minus y min. So subtract those two values and divide it by 2. It's subtract though. Okay, make sure you get that right. That's how to get the amplitude. And the equation of the midline, remember you only have a graph, you don't have an equation at this point. You go y max plus y min divided by 2. Okay, so I will just make sure you understand. This here is the y max, and this here is the y min. And this, the dashed line here, is the midline. Sometimes you have to find one before the other. You have to figure that out. But make sure you know that midline you have to add. With amplitude you subtract. Make sure you have that down, okay? Otherwise you're going to get it wrong. I'm going to box all of this in. And take pictures of your study sheets, guys, because just this morning I had a student say they lost their study sheet and now they have to start from scratch, okay? So that's not fun to be in that position. Okay? So let's use this to figure out determine the characteristics of the sinusoidal function. So the min is just -3, right? So there it is. The max is 7. The amplitude, you decide. Sometimes you can just count using the graph. I would caution against it because sometimes, especially if there's coordinates, use those. So you pick any two. So this is the max, this is the min. I already have that there. I'm going to go max minus min divided by 2. So I'm going to go 7 minus negative 3 divided by 2. Remember, it's negative 3, right? So minus, so this ends up being positive. So it's really 7 plus 3 divided by 2. So the amplitude is 5. The equation of the midline, in this case, I will use max plus min divided by 2. 7 plus negative 3 divided by 2. 7 minus 3 is 4. 4 divided by 2. And that is just 2. And remember, the midline is actually an equation. So there. And so what that means, what you just found is, if you go to 2, right? If you go to 2, that is your midline. And I will make an arrow from the math we just did to it, so you know we didn't know that right from the get-go. And it should split it in half, right? So you count 1, 2, 3, 4, 5 to the bottom, or 1, 2, 3, 4, 5 to the top, so you know you're doing it right. What is the period? I will just go x max 2 minus x max 1. So in this case, x max 2 is 2. I'll call this x max 2, like the x value of the max here, and I'll call this x max 1. So it is 2 minus negative 6 essentially, because it's 3 decimals, we don't really need that. So it'll be 2 plus 6, that's 8. So the period is 8. You should observe that, watch. To go from this one here to the next one here, do you notice that from 2 to 10, that would be 8, right? So we observe that. Okay, so what I would like you to try, hold on. I want you to try, I'm not going to go too many here. Page 7 and page 9. How's that? Page 7 and page 9. I'm going to post the keys to more than just those 2 pages, but those are the ones I would like you to try by tomorrow. One is graphing with an equation, and the other one is extracting from a graph.